Once again, we're going to go through and list all the possible rational roots that you see here. Our factors of p include plus or minus 1 and plus or minus 5. The factors of q include plus or minus 1 and plus or minus 2. This would be nice. So the possible rational roots are p divided by q, 1 over 1, which is 1, plus or minus 5 over 1, which is 5, and plus or minus 1 over 2, and plus or minus 5 over 2. So really we only have 8 possible rational roots. The highest degree number, the total roots that we will have for this polynomial, are 4. So let's go ahead and pick up your graphing calculator again. Graph this out. You guys should be experts at this by now. 2x to the 4th. Remember, if you're using an 84, that you arrow out of the exponent. Plus x cubed minus 11x squared minus 5x plus 5. Let's zoom in a little further. Ooh, that looks nice, right at -1. And that looks like a positive 1/2. Conveniently, -1 and positive 1/2 are possible rational roots. Those are the two that I'm going to start with. Let's check -1. Exponent check, 4, 3, 2, 1, 0. Take all the coefficients. 2, 1, -11, -5, and positive 5. -2 plus positive 1 is a -1. -1 times 1 is a positive 1. -10, when we add down, positive 10, which gives us a positive 5. -5, 0. So yes, this is a root. Great. So we have one root, x plus 1. Now from here, that other root, 1/2, it looked very convincing that that's where it crossed. You can take and now check the 1/2 from what we've already just simplified. So I can say 2, -1, -10, and 5. Bring down the 2, positive 1, 0, 0, -10, -5, 0. Yes, there's another root for us. Woohoo! At this point, we have to be very careful because remember we started at x to the 4th. This is now x cubed. So that means this is x cubed, leaving us with 2x squared down here. Now, we know how to factor binomials, and we know how to factor trinomials. This ends up being a trinomial here. Oh, actually, it's just going to be a binomial because of this 0. So we have 2x squared minus 10. All of this is equal to 0. Each set of parentheses you can individually set equal to 0 at this point. We already know x is equal to -1 and x is equal to positive 1/2. So let's set the 2x squared minus 10 equal to 0 and see what we come up with. So that means x is equal to plus or minus the square root of 5. X is equal to -1 and positive 1/2. Here we have all 4 roots that we were trying to find because this was a degree 4. Example 6, we're going to list all the possible rational roots here. Notice how this is a 1. since that is a leading coefficient of 1, all of the factors of negative 20 will become possible rational roots. So I will just list those. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Use our calculator to graph the polynomial and make an estimate. We have x to the 4th plus 4x cubed minus x squared plus 16x minus 20. If you are finding that your graph is not actually graphing, do you see how this equal sign is shaded in? If for some reason it's not, so let's see, it looks like this. All you need to do to change that to actual graph is press the enter button. Say enter and then an arrow over. It will be shaded in. That means that is what the graph will show when you place it on the graph. Oh, it looks like it crosses at positive 1. Yeah, positive 1. Maybe I'm going to check 1, negative 2, negative 3, negative 4, negative 5. Okay, so I'm going to just put down positive 1 and negative 5. Now, we're not really, I don't think that we're seeing everything, just because this is a 4th degree polynomial. Oh yeah, look how far down it goes, guys. That's super far. So let's change the window on this. Let's say the x maximum, it didn't look like it went too far left and right. So let's change that to negative 20 and positive 20. And then let's change the y minimum values to maybe negative 100 and positive 100. Ah, there it is. There's the little bobble. Do you see it? 1, 2, 3 turns. So there's a turn here and a turn here. So this really only crosses at 2 places. And it kind of looked like we had 2 of them. Now, since it only has 2 real roots, it only crosses twice, what can we make as a conjecture about what the other 2 roots are? Imaginary. Those should be imaginary values because they're not actually crossing the x-axis, but those turns do exist. So let's check the roots that we have. Check positive 1. 4, 3, 2, 1, 0. Okay, take those coefficients. 1, 4, negative 1, 16, and negative 20. 1 times 1 is 1, 5, 5 times 1 is 5. We end up with positive 4. Positive 4 gives us 20, 20, 0. Yes, that is a factor. Great. Let's also check negative 5. Check it with what you just found. 1, 5, 4, 20. The reason we check it with what we just found is it saves us a lot of time. If you were to actually go back and you could check it with the original, that's fine, but ultimately we have to go through and factor this anyway. So this is just getting us a little step closer to factoring. Okay, so I found here that we have x is equal to 1, which means in a set of parentheses that looks like x minus 1. The second set of parentheses is x plus 5. And the third set of parentheses, where did I start? This was x to the 4th, which means this is x cubed. Oh, here's an x squared. Great. X squared plus 4 is equal to 0. So we already know x is going to equal 1 and x is going to equal negative 5. So I set this x squared plus 4 equal to 0, which means x squared is equal to negative 4. Ooh, look at this. The square root of a negative number is imaginary, which we could see that from the graph. It only crossed at 2 places. This was a degree 4. So it had 1, 2, 3 turns to it, but 2 of those were not after it had crossed the x-axis. So here are my imaginary roots. 2 imaginary and 2 real. Oh, I just wrote that wrong. Whoops. That should be a positive 1. I got so excited with that imaginary number. So the answer are plus or minus 2i, negative 5, and positive 1.